Okay, this is our lab program too. So those who are having confusion, let us clear this by this video. So we know that it is using iterative deepening search. Iterative deepening search generally works like depth limit search. If you are having an idea of iterative deepening search and depth limit search, you'll get this program. Before coming to check this program, I request everyone to have a look at DLS and IDS. So fine, well, it gets with this program. So there is a dictionary of list, so which resembles similar to this one. So to resemble this kind of tree, we are just representing it with the dictionary of list. I think everybody get it. So to represent this tree, we are using a dictionary of list. That's it. Okay. Next, coming to our main thing. So our start node and goal node is G, and maximum depth we have given as 4. Okay. So come to here, over here, iterative deepening search is our function call. So it is going to carry our start node as A and goal node as G. And what is our depth limit? Maximum depth is 4. So everything here, it is no doubt here, I guess. So iterative deepening search is having this parameters, and it is going to go for the function definition. So the control goes over here. So while control goes over here, what was this carrying? It is carrying start node as A, goal node as G, and max depth is 4, right? So after getting that, we'll get inside this function definition. We are having one for loop. What is that for loop is saying for us? Range max depth of 4 means the max depth right now it will become as 5. So since our range starts from 0, right now our depth is 0. Okay. Total max depth range is having 5, but right now our depth will become 0. Now, if DLS limit start goal depth, what is start node here? A is our start node. What is our goal node? G is our goal node. But remember, what is our depth? It is 0. So since it is a DFS limit, it is a one more function called the control moves over here, this function definition. Okay. This function definition again carrying the parameters. What is that goal node A? What is that goal G? What is the depth? You have to tell that the depth is 0. Right? Now it will come and check with the first condition. If A equals to G, is that condition satisfying? No, it is not true. So it won't execute. So it won't enter into this block. Next, it will go to this next if statement. If depth limit less than or equals to 0, yes, the condition is true. So this condition is true. It will enter inside this if block and return false. Where it will return false? It return false to this if statement. This if statement, it will return false. Okay. Only this if statement will become false if of false, so it won't execute. Since still our for loop is not become it's not ended, still it is only got iterated for 0. Next, the for loop will iterate for the next time for 1. Now the depth will become 1. Okay, so this and all you remember. I'll just erase this one. Now the depth will become 1. So now the depth will become 1. After depth becoming 1, we'll see this traversing. What happens? Same, the goal node is not changed, the start node is not changed. The start node is A and goal node is G. Only the change here we got is the depth. The depth is 1. Then the control moves from here to here. What it will become? It will is carrying the node A, it is carrying the node G. And what was the depth right now? It is 1. Now if the goal node A equals to G, no, it is not true. So where it goes? It will goes here. If the depth equals to, less than or equals to 0, no, depth is 1. So condition is false. So it won't execute this. Okay. This is not executed. Now there is one more for loop. What is that for loop? Here we are going to get t dot get. This is what key thing you have to observe. What is t? T is actually our dictionary of list. Right now, what it is consist of node. Our node is A. So this get function, you remember carefully, this get function will get the values in a dictionary. Okay. node is A, and what are the values that we are having right now means we are having the values right now as a B, C, D. So these are the values that we are having in our uh, current list means this will give the list. What are the list means B, C, D it will give. Now the neighbor will hold the first value P. Neighbor will now hold the first value P. Now print, so that is for our reference I've given. Don't use this one. If you want to check what is happening, you can use this print neighbor or else not use. Don't concentrate this one. Now inside this for loop, we will be getting if if DFS underscore that is limit neighbor is right now B, goal is G, depth minus one. Depth is one, it will become minus one. That will be nothing but zero. So here internally there is one call. What is this call? This we are going to call as a recursion. Recursion again pointing over here. What is this? Recursion is pointing over here. Neighbor will become uh, now that traversing it will become B and the goal node is G. Depth is zero, right? Depth is zero. Now if node, what is node B equals to Z? No, it is not true. So it is not executed. Now if depth is less than or equals to zero, yes, it is true because depth is zero. So it will enter return false. Where it will return false means it will return false to this if block. This if block it will return false. If is become false but not for loop. For loop next takes with C. It will take C. What happens again same. Now this neighbor will become C and goal node will be same. Now it will check with the C and it will check with the G, right? Our depth is always zero only. Okay, depth is zero only still because it is not get out of the loop. So depth will become zero only. uh, Depth will become 0. After depth becoming 0, again it will check with this C and G. C and G not equal. So again it will execute. Now this again returns this uh, false over here. This entire block will become false. And again next it will chooses D. For D it will check. Again for D it will check. This one it will enter. Now again it will become D and goal node is constant. So it will check with the G and the depth was 0. So D is equals to no, it is not true. It will become over here. Now it will get again false. No, it is not executed. Now what happens? The biggest logic lies over here only. Since it is completed with A, right? Only A traverse. So it is completed. It is entire thing is completed. So it will return false. Where it will return false means this entire thing will return false over here. This if block will become false. Now remember the depth was 1 right now. Now it will become the depth for 2. So the important thing lies with the 2 only. So we'll just understand what happens at the depth 2. So now you remember when the depth becomes 2. So the same state, the start state is A and the goal state is G and the depth is 2. Now it will go over here. So it will go over here. What it is carrying? Same A, goal node is G and the depth is only increased, that is 2. So A is 2. Now is the goal node is equals to our node? No, it is not executed. Is depth is equals to less than or equals to 0? No, it is not true. Now it will come again over here. Our coming over here, what is the node? A, right? A children's will be B, C, D. B, C, D. Here you have to observe carefully B, C, D. Now this B will become neighbor, right? Now if depth limit bg, now here the depth won't become 0. Now it is like 2 minus 1. Here is the magic over here. So 2 minus 1 it will go for recursion. So when it goes for recursion, again it is, see, you have to assume that the original call was with A. Now it is internal recursion. Now you have to assume like a stack. Okay, original recursion was original call was with A. So A is having inside, but on top of it, what we are going to get? We are going to get for B right now. So B is going to get executed now. Check what happens. B and G, the depth limit is now 1. Now if node equals to goal return true, it is not executed since B is not equals to 0. If depth limit less than or equals to 0, it is also not executed. Now it will come over here. Now what happens? Now here this is a recursion. It will take node as B. So what is the node is B here. So for this node, what are the children's? For this node, E and F are the children. So the list will be now we are having for recursion E and F. The recursion will be having E and F. So E and F will be given in our list. So this is for this one. For B, you have to assume. Okay. Now what happens? It will neighbor will become E. Okay, goal will become G, and again it will go for this checkup. Okay, this will check with this node. What is that node? E is equals to G. No, it is not. Depth. What is the depth? Now, sorry, I forgot to tell. Actually, depth was carrying one, right? Now it will become zero. Now it will come. Yes, depth is zero. Now where it will goes? It will return false to this if block. Again, you have to assume that the for loop is not terminated because still we are having F. It will traverse with F. The same thing happens with F. So it has traversed initially with the E. Now it will traverse with F. Now after F also the depth will be zero for E and F. Why? Because it was carrying B was carrying one. Now it will become zero. Now it happens. Now what happens again? The same thing. It will return false. Now this entire for loop will be terminated. Why? Because this is all it has traversed. But what has actually traversed? It is traversed with only B. Okay. Now C is left and D is left. See, internally recursion happen and it is traversing with the B. Now again, we'll coming out of that main function call. That is our BCD. Now it will traverse with the BCD. So if you are getting confusion, you have to analyze that there is a recursion call. One is for B children's and the outside is for B, C, D. Okay. Now B traversing is completed. Now see how C will traverse. Check one.